Okay, so now on to the last section here. We're basically going to be following the exact same operations. In this one, you can see that our two denominators are the same, but over here we have a 1, right? So again, we're just going to, LCD here is just, x minus 3. Multiply everything times the x minus 3. And what's nice about that is, obviously that's going to divide out both of these denominators, but we're going to have x times x minus 3 over here, and then we'll have a plus 4x because that denominator divide out, and then that's going to equal a 12 because those divide out. So again, we're multiplying this times everything. Okay, so now let's just go ahead and simplify this. So we get a x squared minus 3x plus 4x equals 12. And then again, since this is a quadratic, I want to have this equal to 0. So I'm going to subtract a 12 to the other side, but I'll get this to be an x squared plus x equals 12 equals 0. Oops. Oops, minus 12. All right, and now I want to go ahead and factor this. And by factoring this, I will get a x plus 4 times an x minus 3 equals 0. Apply the zero product property, set them both equal to 0, and I get x equals negative 4 and x equals 3. Now when I go ahead and plug these back in, what I notice is I can plug negative 4 in for any x, and that's good, but when I plug in 3 here, it makes my denominator equal to 0. So therefore, this is an extraneous solution. It's a solution, but to the simplified answer, it's a solution to the simplified answer, but it's not a solution to the original expression or the original equation, okay? Over here, it's very similar. Again, I have a number here, 2, so I'm going to write that as a fraction. Here, I can factor this into x times x plus 1. So therefore, you can see that my common denominator of 1, x plus 1, and x times x plus 1 is just going to be x times x plus 1. So I'll multiply everything times the common denominator. And again, to get rid of all of my, so I won't have any more denominators. All right, so I'm just going to multiply this. That will give me a 2 times a x times x plus 1, just using parentheses to represent that multiplication. When I multiply it times this fraction, the x plus 1's divide out, so I'm just left with a 1 times x. You don't really need to write the 1, but just for accounting purposes, I will. And then over here, you can see the x's, when I multiply it times this fraction, the x and the x plus 1's divide out, so I'm just going to be left with 1. Now let's go ahead and simplify this. I get a 2x squared, right? 2 times x is 2x, so 2x times x, and then 2x times 1, which is going to be a positive 2x, plus x equals 1. Again, this is a quadratic, so I'm going to want to combine like terms and get this set equal to 0. So therefore, I have a 2x plus 3x minus 1 equals 0. All right, so now basically I want to see, well, is this again like factorable? So I say 2x times x. All right, and I need this to give me a, I need the multiply to give me a positive 1 or negative 1, but then they need to add to give me a positive 4x. So basically what I'm doing is I'm finding the difference. However, the larger product needs to be positive. And the problem here is, if I put this as like, it doesn't matter where I put the 1 or the negative 1, I'm never going to have a difference between these two products be equaling 4x. Like for instance, if I put a 1 here and a negative 1 here, I'm never going to get a difference of my inner and my outer to be 3x. So therefore, I'm seeing this as non-factorable. So before I go ahead and check, because I did the solutions earlier, I don't remember exactly on this one, so I'm just going to go back and check my work here. That gives me a 2x, which would give me a 2x squared plus 2x. Yep, that would just give me, oh, there's supposed to be an x there. The x plus 1's divided out. That gives me an x, right? That's good there. And that gives me 1. Yeah, so therefore this is oops, that's a squared. Therefore, this is non-factorable, so since I can't factor it, what I'm going to do is the quadratic formula. So remember quadratic formula, x is equal to opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, so now let's just go and plug in our solutions here. So we have opposite of b, which is a negative 3, plus or minus. Actually, before I even do that, let's go ahead and determine the discriminant to see if there's actually any real solutions. So I'm just going to do b squared minus 4 times A times C. And what I get here is 9 minus, so that would be 3 squared minus 4 times 2 times a negative 1. Okay, so that will give me a discriminant here. This gives me 9, and then that's a negative 8. So that's a positive 8, so plus 8. So that gives me the square root of 17. So that's nice, so I can just go ahead and write that in there. Square root of 17 over 2 times A, which is 2 times A, which would be 4. Okay, well, obviously, I see the only numbers that make this 0 is going to be 0 and negative 1. And these are my two solutions, and they're not 0 or negative 1. So therefore, they are both good solutions, not extraneous. Okay, so just remember, a lot of times when you have this quadratic, you're going to get some problems that can be factorable and could have extraneous. Or if it's non-factorable, like use the quadratic formula to go ahead and solve it. All right, on to the next one. So this one kind of looks like, again, what we did previously, where we have something factorable into given our two solutions. So I have x plus 5 times an x minus 2. That works as the factoring form. So therefore, that is going to be our LCD equals, so x plus 5 times x minus 2. So I'm going to multiply everything times this, and so x plus 5 times x minus 2. And again, I'm doing that to eliminate all of my denominators. So when I multiply it times this expression, my x plus 5's divide out, and I'm just going to be left with a 3x times x minus 2. When I multiply it times this expression, my x minus 2's divide out, and I'll just be left with a 1 times x plus 5. So that'll be an x plus 5. And that equals multiplying it times this, multiplying it times this expression is going to divide out both of my denominators, so that's just going to be equal to a 7. All right, so now let's distribute a property here. So I get a 3x squared minus 6x plus x plus 5 equals 7. Again, it's a quadratic equation, so I'm going to set this equal to 0. So 3x squared minus 5x. And then subtract the 7, so that would be a minus 2 equals 0. Okay, so again, I want to check if this is factorable. So I know that all quadratics can be factored down into a product of two binomials. Okay, let's see here. They are going to be a difference since my last term is negative, and the larger of the products has to be negative. So therefore, I need this to be 3 times negative 2 gives me a negative 6, and then positive 1 will give me a positive 1. And that works because 1 times negative 2 is negative 2, 3x times x is 3x, and then these two give us our middle term, negative 6x, positive x. So now I can just set these both equal to 0 and solve, and I'd get x is equal to a negative 1/3 and x is equal to 2. And again, we see that I can plug in a negative 1/3 both of these, but I cannot plug in the 2. So therefore, this is an extraneous solution. It works for the simplified expression, but it does not satisfy the original equation. All right, on to the next one. So next one, again, I can factor out the x. So that's going to be an x plus 1. All right, and that's, let's do a different color. Let's do a darker blue. So I can say my LCD in this case is going to be x times x plus 1. So we'll multiply everything times x plus 1. Okay, when I multiply it times this first expression, the x's divide out, so I'm left with a x minus 3 times an x plus 1. When I multiply it times this expression, the x plus 1's divide out. Be careful of that negative. So that's a negative 3 times x. And then when I multiply it times the last expression, the denominators both divide out, and I'm left with a negative 3. Okay, so here I need to multiply the binomial. You could use FOIL. I'm going to do a little bit more of the math in my head. So I get an x squared, that's a negative 3x, that's a positive x, so that's going to be a minus 2x. Minus 3 minus 3x equals negative 3. Again, it's a quadratic, so I'm going to want to set this equal to 0. So I get an x squared, let's see, minus 5x, and if I add the 3 over, I'm going to get 0. So now in this case, I can, I don't need to like factor a trinomial anymore because it's not a trinomial. So I can just factor out an x, and I'm left with an x minus 5 is equal to 0. And now I can use the zero product rate, say x is equal to 0 and x is equal to 5. And again, you can see that when I plug 0 back into this equation, I get an extraneous solution. So that is going to be extraneous as well. All right, on to the last two. So again, in this one here, we have 1 and we have 1. So the LCD is pretty easy to find. It's just x minus 1. So I'll multiply everything times x minus 1. When I multiply it times this one, the x minus 1's divide out, and I'm just left with a 2. Multiply here, I'm going to have x times x minus 1, and then e times 5 times x minus 1. Okay, so let's go ahead and simplify by applying distributive property to get rid of the parentheses. So I have 2 plus x squared minus x is equal to 5x minus 5. Now it's a quadratic, so I'm going to want to get everything to the same side, set it equal to 0. So therefore, I'm going to have to subtract a 5x to both sides and add a 5 to both sides. So when doing that, I get an x squared minus 6x plus 7 is equal to 0. So now, in this case, what I'm doing is I'm going to try to factor, but I notice my last term is positive, and that means I'm trying to find a sum. And so that means I'm trying to find a sum of 1 and 7, which are the factors of 7, which are the factors that multiply to give me 7 that add to give me a negative 6. But they have to add. Well, negative 1 and negative 7 give me negative 8, and positive 1 and positive 7 give me positive 8. So I'm not going to find a sum that's going to give me a negative 6. So this is non-factorable. So what I'm going to do before I do the whole quadratic formula, let's just do the discriminant to see if it's actually any real solutions. So when doing this, I do b squared, which is negative 6, squared minus 4 times a, which is 1, times b, which is, or c, which is 7. And what I get here is 36 minus 4 times, oh, that does work. So that does work, so I can use the quadratic formula for that one. I wonder if I made a mistake on that other one. I'll have to go back and check, because I don't remember doing the quadratic formula for 2 of them. So b squared, that's going to be 36 minus 4 times a times c, which is 28. So therefore, that's the square root of 8, which can be reduced down to 2 square root of 2. Okay, well, I guess we'll just work on it, and then we'll go back and check my answer. So x equals opposite b, which is 6, plus or minus 2 square root of 2, divided by 2 times a, which is 2. I can divide that into them, so x is equal to 3 plus or minus the square root of 2. And obviously, when plugging those back into this equation, those are both going to work, so that's not extraneous. So let me just make sure that's 2. That gives you x times x, and that gives you a 5x minus 1. So x squared, 5x minus 5. That's x squared minus x. That'd be a negative 6x. That's plus 7. I mean, that looks great. Let me just double check this one, the other one where I did quadratic formula. So my common denominator is x plus 2. So that gives me a 2x times x plus 1, which is 2x squared plus 2x. This multiplies to give me an x, and then that gives me a 1. That gives me a 2x minus 3, right? I mean, works. 4 times a times c. b squared minus 4 times a times c. All right, I'm not seeing any example, but maybe obviously, maybe I'll just have to go back and look at my work and see. Maybe I did do it that way. I don't remember, but maybe I did. Or if I made a mistake, I'm sure people will comment and I'll figure it out. All right, last example here is, again, we can factor that down to x plus 4 times an x minus 1. You can see that shares with those denominators. Let's use green. So I can see my LCD in this case is going to be an x plus 4 times x minus 1. So I'm going to multiply everything times an x plus 4 times an x minus 1. When multiplying it times this first expression, the x plus 4's divide out, so I'm left with a 4x times x minus 1. When multiplying it times the second expression, I get the x minus 1's divide out, so I'm left with a positive 5 times x plus 4. And when I multiply by the last one, I am left with a 15. Just the denominators both divide out. So now let's go ahead and apply distributive property here. So I'm left with a 4x squared minus 4 plus 5x plus 20 is equal to a 15. Again, we have a quadratic, so we're going to simplify all this. So 4x squared plus 5x. Let's see, that becomes a 16. And so 5, so let's just write out. So that's 16 plus 16 equals 15. So I'll have to subtract a 15 on both sides. So I'm left with a 4x squared plus 5x plus 1 equals 0. All right, so when I go ahead and factor this, again, this can be a product of two factors. So let's just do 4x. Let's try this first. X equals 0. Now again, they need to multiply to give me 1, and since that's adding, we're going to find the sum to give us a 5x. And well, that one's not too hard to find, and that sum has to be a positive. So therefore, we can see it's going to be plus 1 and plus 1. So therefore, by using the zero product property, I get a negative 1/4, and x is equal to negative 1. But you see, we can plug in a negative 1 actually, so that one works, as well as negative 4. So they both check out. So there you go, ladies and gentlemen. I believe I had one where both solutions didn't work out, but I guess I either made a mistake typing it up or I made a mistake in the video. But either way, that at least is the process for you to follow, identifying the LCD, multiplying them, not always multiplying all the LCD because a lot of times they're going to share a common denominator. But once you have identified that least common denominator, multiply everything so you get an equation that is with no more denominators. And once you have an equation with no more denominators, you can either solve it as a linear equation by getting, isolating the x, or if it's a quadratic, you can solve by factoring or the quadratic formula. And then once you get your two solutions, plug them back in to make sure that they don't make the denominator 0. And if they do make the denominator equal 0, then they are extraneous. So hopefully you guys enjoyed. I'll see you guys in the next one. Cheers.